Hello everyone, today we will talk about the segment tree. So it is a good concept and it is widely used in mostly medium and hard marked problems. Uh, so segment tree is an advanced concept. It is based on binary tree data structure. You already know, right? Binary tree. So this segment tree concept is based on binary data structure. Okay, that means it will consist of a root node and child, its child. Okay, every node um, will consist of some intervals and resultant value. Okay, so it is based on the binary tree. Okay, every node will consist of some interval and it is where to use. The most important question is where to use the segment tree, right? Whenever there is there will be some query, right? For example, to find the range type problem, right? Like if there is a array of numbers 1 3 5 7 9, right, and so on, and we have to find the summation, or let's say multiplication of product of the numbers in x range or y range, right? In that way, in that question, we can use this segment tree, right? Whenever there is a query based on ranges, okay, either maximum or minimum in that range, you will use the basic operation, you will use the segment tree. Okay, so let's about the time complexity. So the time complexity of building the segment tree is O of n, and updating, let me write it, for building it is O of n time complexity, updating again O of log n. Why? Because updating you will move towards the height, right? You will move in this vertical manner, so the height is log n, that's why it is O of log n. Okay, for query it is O of log n again. Okay, and see, you can see it's a good approach, right? It has good time complexity. So let's talk about its implementation, right? So let me take an array. Let's say there is an array of 0 1 3 5 minus 2 and 3. Okay, so in this segment tree, what we used to do is that it is in such a way, let's say 1 2 3 4 5 6, there are 6 elements, right? So we will make like this 6 node at the base, 2 3 4 5 6. Okay, this one will be 0 1 3 5 minus 2 and 3. Okay, let's do first of all the from the top wise. Okay, let's do from the top wise. Let's do here only. What is it? It is 0 1 3 5 minus 2 and 3. 1 3 5 minus 2 and 3, right? Then what we do, there is a root node, okay, which contain all these elements. It will cover all this element in the form of indexes, right? So it is 0 1 2 3 4 and 5. So it will cover 0 to 5 range. Okay, currently its value is not decided. Okay, now it have two nodes. Its index is 0, of course its index is 0. Okay. Now its left child, its right child. Okay, so the left child index is 2 into the left side is equals to 2 into index of root plus 1. Okay, or parent plus 1, and the right one is 2 into index plus 2. So 2 into index 0 plus 1, that means 1. So index is equals to 1. Here index will be 2 into 0 plus 2, yani 2. Okay, and it will cover the range that will be 0 mid. Okay, that means let's say it is 0, left is equals to 0, left is 0 and right is, we are using as a pointer. Okay, we are pointing left to the right 0th index and right to the rightmost index, that is 5. Okay, why I'm doing so? Because when I will take out the mid value, then the left will point from the left child will point from left to mid, and this will point from mid plus 1 to right. Okay, that means 0 to 0 plus 5 divided by 2, that means 2, right? So 0 to 2, and this will point to 3 to 5, 3 4 5. Okay, let's divide it further. So this will be left child, right child, so again left, right child. So again its index is, the left index is 2. Now 2 into index, that means 2 into 1 2 plus 1 3, index is equals to 3. This index will be plus 1 4, right? 2 into 1 2 plus 2 4. Okay, what is about this? This index will be 2 2 is 4 plus 1 5, and this will be 6, right? Index will be 6. Okay, now index, what will be its value? It is not decided yet, but the or the range will be 0 plus 2 divided by 2, that means 2 divided by 2 1, that means 0 to 1, 0 to 1, and this range will be 2 only, right? 2 to 2. Now the range of this will be 5 plus 3 8 divided by 2, that is 4, that means 3 to 4, and this will be only 5, right? 5 to 5. Okay, now this cannot be divided, but this can be further divided, right? So the index will be index will be 3 to 6 plus 1 7, and this index will be 3 to 6 plus 2 8, and the value will be range will be 0 to 0. Okay, because 0 plus 1 1 divided by 2 0, and this will be 1 to 1. Now this index will be, now this node will also be divided, right? So the index will be, say index will be 5 to the 10 plus 1 11, and this index will be 12. Range will be 3 to 3, and this range will be 4 to 4. Now since I am at leaf node, so I will return the element of that index only, right? So 0 comma 0, that means 0th index of the array, element at the 0th index is 0, right? So I will return, so the value will be 0. Okay, now 1th index will be 1 at the index 2, that means 2, value of the element at index 2 in the array. Okay, that is 3, right? Now At index 3 it is 5, at index 4 it is -2, at index 5 it is 3, right? Suppose now, as you can see, if we have to find the summation, right, of the summation, so what I can do, I can simply add this both, and the value of the both summation will be here. So if there will be query of finding the summation from 0 to 1, then simply I can return from there only, because this will represent the summation of range 0 to 1. If I have to do multiplication, if I have to find the multiplication of range 0 to 1, then simply I will do this all, and at last when I have to return, store the value of the parent index from the leaf nodes, then I will simply do the multiplication of both, right? Suppose, let's say it's the summation part, okay? So what I will do, I will sum it up. So I will be summing, then it will be answer 1. So what this says, that in range 0 to 1 the summation is 1, okay, and this value is stored in at index 3 of in segment tree, okay. Now what I will do same here, 5 plus -2, that means 3, so it will be here 3. Now what I will do, I will again sum it up, 3 plus 1 4, that means 4, that means 0 to 2, from range 0 to 2 the summation will be 4. See, 3 1 4, okay. Now I will sum it up again, 3 plus 3 6, so it will be 6, right? So as you can see, from index 3 to 5 the summation will be 6. From 3 to 5, 5 6 7 8 minus 2 6, see, and 6 plus 4 10. That means from index 0 to index 5 the summation will be 10. You can already sum it, 5 6 7 8 minus 2 6, 6 plus 3 9 plus 1 10, so index is 10. So if you have to find the multiplication, what you will do, you will simply multiply it, 1 into 0 0, and then again this will also become 0, and then overall it will become 0, right? Hope you get it, right? It is nothing but a binary tree only, okay. You should know about some dividing concept, right? Finding the mid, there is nothing else, only okay, there this is just a visualization process, but behind this process we store all this value in an array or vector, okay. In C++ it is vector, or in Java it is array list, okay. So we store all this in an array. It is just a visualization that it is a tree, but it is all about, it's an array, okay, because this is storing at 1. So if you convert this into the array, okay, if you want you can convert this into the array, you have to simply note down the index. As you can see, it is stored at index 0. So if I make it, okay, so at index 0 it is value is 10, at index 1 its value is 4, at index 2 its value is 6, at index 3 its value is 1, at index 4 its value is 3, it's at index 5 its value is 3 again, 6 its value is 3, 7 0, 8 1, and what's this, at index 5 6 7 8, okay. At index 11 it's okay, 8 9 10 11 and 12. At index 11 it is 5 and -2, okay. Overall the index is, there are 12, 2 are vacant. So in binary it is represented at like this, where the root index is this one, alright. So this is just a visualization, but behind the process it is stored in the form of array. Okay, so let me code it so that you can get a better understanding. But again, uh, for simplicity, for better understanding, I am again going to the process just for the summarizing what I have done. That this is an array. Okay, for building into the segment tree, what we have to do, simply create a node. Okay, not really creating a node, it's just taking a root node, okay, which will represent the whole series from range 0 to array size. Okay, and the value will not be decided in starting. We will divide it when we got a leaf node. We will be returning the value of the array, filling it in that node, and when we will be at parent node, we will be doing operation on both on the child nodes, and the value will be put in the parent node. In this way, the topmost node will represent the value of the whole array. Okay, and when we have to update it anything, let's say I have to update from index at index 2, I have to update the 3 to 10. Okay, let's say I have to update it, right? Let's say I have to update at index 3, at index 2 the value will be 10. Okay, let's say. So how I will update? I will simply see in the range 0 to 5, I will find out the mid value, it's 2. Okay, so the index is also 2, so that means it will come in the left hand side, because right hand side it is mid plus 1, right? So here the mid is 2 and the index is also 2, so I will go on the left hand side. Again I will check this, the series, the node cover, so 0 to 2, again left and right. So 0 plus 2 divided by 2, that means 1. I will abort it because 0 to 1 indexes are only covered. I have to find the index 2, right? So I will move the right hand side, so I will see both left and right, both are pointing to index 2, and index 2 is same as 2, so I will then and there only update 3 to 10. Okay, when I will be returning, I will update the answer also. That means I will update the segment tree also by I will return 10, then 10 plus 1 11, then it will become 11, right? So as you can see, it will become 11. Okay, it will become 11. Previously it was 4, but now it will become 11. That means 0 to 2, it will be now 11. 10 plus 1 11. Okay, then at last 10 plus 6, it will be 17. So as you can see, with minimum operation I have updated and also find the answer of the whole series, right? Suppose I have to update and then the next operation we find the summation of the whole array, right? So it's easy. The moment I update, I can find the I can give the answer by sending the value of the root node, right? There can be question ki first update it and then find the summation of this whole series, and this can be asked multiple times, right? Update this, then find this summation of the whole series, then update this, then find the summation of the whole series, then this can be multiplied by 10 times. So will you do it continuously in brute force way, or you can use the segment tree, use this method, right? The updation time is O of log n. I think it's a good complexity, very good complexity. With minimum time you will get the answer. It is asked in good number of companies, in good number of frequencies, and it is a good method also, of course. So now I will be doing the building method, updation method and query method. Okay, in code, and then only we will try to get a better understanding. Okay. Implementation of segment tree. Okay, so first I will make a class segment tree. Okay, uh, I will make it I will make the tree whole segment tree in the form of array, because I told you na behind the scene it is in the form of array, and the size will be of n. Okay, of integer tree. Okay, now click segment tree. Here I will pass array, and the moment I create the object of segment tree, the constructor will be invoked, and there from there I will pass an array also. So uh, it is said that, and it is generally followed, that the size of the tree array, it's four times the size of the array. Okay, original array, because you have already seen, right, ki the array was of size 5 and the indexing was going to 11, 12. All right, what about the bigger size of array? So for the safe, we take four times of the size of the original array. Okay, so n is equals to array dot size. I will resize tree. Okay, when it's correct. All right, now I will do the building process. Okay, now I will build this word build. It will take vector. The node will represent the index of the node of the segment tree, right? Some node have index 11, 12. You already know, right? So node will cover the index of this tree, this tree indexes, right? So node is the index of this tree vector. Okay, and it will, every node will cover some range. Let's say integer left. Okay, integer left, integer right. I will denote left to L. Okay, here then integer right. Hope so everything is good. Let's see if we will require, we will just use it. Okay, so in building, what we were doing, we were just taking nodes, dividing the range from taking mid and dividing the range, right? The moment we reach at the leaf node, what we were doing, we were just storing the value from the original array, and we just pass it to the parent, and then on in parent node we were just operating the child node values and storing the resultant into the parent node, right? So the moment we are at the leaf node, that means if left is equals to right, that means we are at leaf node at the bottom most case, right? So what we will do, we will simply tree at index node. Okay, tree at index node is equals to array of that left or right. Okay, because both are same, we will just store it and just we will return it. Okay, okay, after returning, what we will do when we will be at parent node, so what we will do, we will just uh, operate on the child nodes and store the value in the parent node, right? If there is summation, what we will do, we will add the values in the child node, right? We'll add the values of both the left and right child node, we will store the result in the parent node, right? So what I'm going to do, I'm storing tree of node is equals to tree of left child value. Sorry, it is left, no, we can write left child as 2 into node plus 1, right? And plus of 2 into node plus 2, right? So 2 into node plus 1 is the left index, means this is the index. 2 into node plus 1, it is the index of the tree of the left node, right? It is the index of left node of the tree, and 2 into node plus 2 is the index of the right one, right? So I'm just adding both of them and I will store in the node. Then this node will be the left node of someone else parent node, right? So it is just a recursion. Okay, so I will finding the mid value, left plus r minus r divided minus 2, that is good. Okay, building, so it will be array. The left node, first I will make the left node, so the index will be of course 2 into node plus 1. Okay, then left and then mid. Okay, the right one will be the mid part, the right. So it, the left node will cover from left to mid portion, and the right node will cover from mid plus 1 to right. Okay, and then at last we will return. Okay, now I will be making update function, update routine. Okay, void update. So this will be the vector of entire array. There will be some index which we have to update. Okay, and there will be node of, yes, of course this will again uh, okay, so this will be the original array. So this will be the original array. This is the index at which we have to update the value. This value will, this is the update new value, right? And this is the node. This will point the, this will be the index of the tree vector, left and right, this will be the covering series. Okay, now if again I am at left is equals to right, and left is equals to index, what it means that I am at the leaf, I am at the leaf node. Okay, and that is the same index which I have to update, right? That means I have find the index. Okay, hope so you got it. So what I will do, the moment I will reach there, I can update my array also and update my tree node also. Okay, node will point the index as always. Okay, then again if I didn't, then I will just divide it. The moment that that same approach by while building, divide it, going to left and right, but before going to left and right we will check whether the index belongs to the left range or the right range, right? So int mid is equal to left plus right minus L divided by 2, of course. If index will be greater than mid, okay, that means it lies in the rightmost portion. So what I will do, I will move on the right index which have the right node which have the index of 2 into node plus 2. I will pass the value index and array. Now that will cover from the range mid plus 1 to right. Okay, if the index does not lie in the range of mid plus 1 to r, that means right, so that means it will be in the left node, right? So I will be moving to the left node and covering that range and trying to find the index. Then again, that same divide and uh, moving right. The moment I will reach at the index, right, left and right will become equal. That means I am at the leaf node, and that node will is the index which I have to update. I will simply update it and I will return it. After returning, I will update the value and then return again, and simply the recursion process, right? Now last is the query, right? Query method. So what is required in query? In query, as we have already seen, there will be some range, right? And we have to find either summation or multiplication or maximum or minimum of those range, right? So there will be some range. I am denoting it as QL. That means query left, but means that specific range. Left part means the starting part of that range, right? Question range. And int query right, okay. And then there will be what I can say, node, of course. There will be an index, okay. And then again there will be integer left, integer right, okay. So this is showing because I have already done it, okay. So there will be a case, right? uh, Try to imagine it. Suppose there is a long array, okay. Try to imagine it. There is a long array and you have given a range. So what are the possibilities that the range will cover or not? That means there is a big range, big array size, and there is a small range. So what is the possibility that any particular index is being which is in array, which is in that range, query range, and also in the tree, also in the big size of that array, original array, okay. That means any particular index should be uh, in the query range as well as in the tree range. That is the that's the you say, then only it is a valid answer, right? It will be counted in the answer. What I'm trying to say is, let's say there is an array, okay. Okay, there, let's say there is an array, so something something, okay. So this is a big array, right? So what we have to do, and the query range is only this much, right? The query range is only this much. This is the query range. So there can be a scenario that my left is pointing to what? Let me make it bigger one, okay. There is a much possibility that my left portion may be covering to this much, right? Or there will be also be a possibility that it may overlap, like this. So there can be a possibility that it may cover half of the portion. There can be possibility that it may cover no portion, right? It means it start here and it's here. So there can be three possibility. If it covers no portion of the query range, it may cover half of the portion, or it may cover the full portion, as you can see. So what I'm going to do is that if That means no overlapping, right? If there will be no overlapping, what will be the case? Then my left will be my leftmost range will be less than, right, query range. That means whatever the range, let's say the left and right are covering the range, right? So maybe the left one is uh, um, what can be the case? The left, the left one may be here, and the right one may be start less than the starting range, right? Starting query range, or that means like this way, that my left, my L is less than, or my less than QL, and my right is also less than uh, QL, query L. That means it ends in starting only. Or my left is greater than QR, and of course R will also be greater than QR. Or we can, in simply we can write my right is less than QL. If my right is less than QL, that means my left is also less than QL. And like this way, means if my right right is less than QL, and my left, or my left is greater than QR, right? Then what I will do, I will simply return 0, right? Okay. Let's make it integer because it will be returning something. Now, if let's say this is the query portion and my range is covering from here to here, that means it covers the part of the query range, right? It means complete overlap. The whole range falls in the query range. Okay, then what I will do, if my left, right, my left is greater than, means my left is greater than the query left, right, or equals to query left, and my right is less than or equals to query right, then what I will do, I will simply return the tree node, tree at simple, right? uh, or if there will be the partial, the only case left is partial, right? So simply what I can do, I will divide it until and unless my range covers the uh, full query range, right? So simply I will divide it, L plus right minus left divided by 2, simply return addition of both. Okay, if the, those that portion which will not cover, it will return 0, and the portion that will cover, it will return the answer. So simply I will return query of query left, query right, node. Okay, this will cover the left portion and this will be covering the right portion. I will return the summation of both the portion. Okay. This is done. Now I will make call this all. Okay. Let me write the boilerplate. Measure array. So segment tree, right? Segment tree array this. So okay. I will take this that same array only 0 comma 1 comma 3 comma 4 7 9. Okay, this is another array. Okay, showing error. Update. mm, Update array index node, right? So the array first, I think. Array index node, huh? No, it's correct. Something else. Too few arguments and function call. Array 0 10 0. And index. This update array. Let me give it again. Date. First of all, I will provide the array and index which I have to update. Let's say I will convert this 3 into 10. Okay, so 0 1 2, I will provide index 2. Then node will be 0 only, right? I will provide the root node which is of index 0. Value I will make it 10. Then index left, of course, 0. And index right, that is array dot size minus 1. Okay. Okay, so let's say first I will build it. I will provide the query that from 0 to 4. See, query 0 to 4. So from 0 to 4, uh, we have to find the summation from 0 to 4. Okay, so the answer will be 0 to 4, 0 1 2 3 4 2. So it will be 7 8 9 10 15, right? 15. Okay, when I will update it, what will be the next one? 0 to 4 again, 0 1 2 3 4. Okay, 7 4 11 11 and then 10, 11 and 10 21 22. It should be 22, right? So let's check it out. Okay, so see, the answer is coming as we have predicted, right? This was good. Okay, this was all about. So we have defined a class segment tree. That's all. Hope you get it. um, Next time we will try to do some lead code problems also on segment tree basis, because it is a good topic and it is asked in many interviews in good companies, in product based companies also. So yes, we will get a better grip on this topic. And of course today's POTD is easy, that's why I didn't make the video of today. It is an easy mark problem, you can easily do it. Okay, thank you.